Hello once again and welcome to another digital homework with me, Teacher John. I'm the homeroom teacher at grade 11 here at Mataneedol High School. Today we're going to be looking at the magical world, and it is magical, of triangles. And first of all I want to start off with some vocabulary, some important English words that you need to know. So here I have a right-angled triangle. You see the right angle in the bottom left-hand corner as you look. You've got the two sides forming the right angle, side A and side B. And then we have the longest line of the right angle triangle, which is called the hypotenuse. The hypotenuse, not to be confused with, get rid of that, not to be confused with hippopotamus. Okay, hypotenuse. Okay, now Pythagoras was a Greek mathematician way many years ago, and he formulated an idea that the sum of the squares of the straight lines that form the right angle add up to the square of the hypotenuse. So A times A plus B times B equals C times C. And we can prove that quite simply. Here's a picture of the great man. I'm not a great fan of the graphics there. It says A squared and B squared as though that's the measurement. You don't just add one side is A squared, one side is B squared. One side is A, one side is B, and the hypotenuse is C. So I'm going to rearrange a triangle A, B and C like so. Okay, so you can see there are four triangles pieced together around the outside of what ends up as a square of side hypotenuse length C in the middle. Now, how do I know it's going to be a square? Quite simply because we know that that's a right angle in that corner there. Therefore, that angle, the blue angle and the green angle, have to add up to 90 degrees. So the blue angle there and the green angle there adds up to 90. So that angle C in the middle has to be 90 degrees. It has to be a perfect right angle. And the proof to Pythagoras' theorem, I'm going to try and keep that there so you can see it at the same time. The area of the shape, the big square, is A plus B multiplied by A plus B. And that equals, if you expand those brackets, A squared plus 2AB plus B squared. Now at the same time you can also add up the four, or the five I should say, the four triangles and the big square to get the same answer. So it's the sum of the shapes making up the big square, and that equals 4 times AB over 2. Remember that the area of a triangle is the base times the height divided by 2, so 4AB plus C squared, and that equals 2AB plus C squared. So A squared plus 2AB plus B squared equals 2AB plus C squared. We can take 2AB out from both sides and prove Pythagoras' theorem: A squared plus B squared equals C squared. And that works for triangles of any size that are right-angled triangles. I could have taken a really thin triangle and it would still work. Okay, I hope that was informative. Thank you very much.